But today, guys, we're going to start looking at one more form of quadratics, our last form that we're going to talk about here today. And it's going to be titled graphing f of x equals a times x minus p times x minus q. I like to call this form right here. They're going to title it intercept form. I like to call it x-intercept form. Okay? I like to call this x-intercept form right here. A little squeaky this morning. And the question we're trying to answer today, what are some of the characteristics of the graph of f of x equals a times x minus p times x minus q? Kids, notice what variable is still out front again. A. Now, A is going to determine whether we have a U shape or an arch. And that's also going to determine vertical shrink or vertical stretch, just like we have seen in the past. Okay? So to answer that question, we're going to look at graphing quadratic functions of the form f of x equals a times x minus p times x minus q. We're going to use intercept form. There's that name, intercept form, to find what? Zeros of functions. Good. And then we're going to use those characteristics to graph and write quadratic functions. All right. So there's a lot in here, but I got to be honest with you. I think it's pretty straightforward today. All right. The vocabulary is really lengthy today. Really, really lengthy. Intercept form. Anybody want to read that for me?
Quadratic function of the form y of a x minus b times x minus q. P and q are the values of x.
Okay, so what we're really going to focus on today, kids, in intercept form is this. If we have a quadratic that's graphed, say maybe this right here, we're really worried about this point and this point. We want to know what are the x-intercept values. Okay, that's all we're really talking about. And we're going to use those x-intercept values to use it to find a line of symmetry. And once you've located a line of symmetry, we can use the line of symmetry to find which point, kids. Absolutely. So let's jump right into this. Kind of giving you a detailed way of doing this right here. You don't necessarily have to follow these, but I think that this is a good way of going about this. We're going to graph f of x equals a times x minus p times x minus q. Now guys, do you see an a value out in front of this function we're about to graph? If there's no value out there, assume what value? 1. So you might say, okay, this is a 1. Guys, is that 1 positive or negative? Give me a U shape or an arch then. We know we're going to have a U, don't we? Okay, so the first thing it says to do is locate your x-intercepts. And here's how you do this. All right? This x minus p and this x minus q part, there's two parts right here in parentheses. What you do to locate your x-intercepts is the following. You set both parts equal to 0. We're going to locate the zeros. We're going to set x minus 1 equal to 0. And we're going to set x plus 3 equal to 0. Okay? Guys, what would make this first statement true for an x value? 1. Okay, so we've got x equal 1. I'm going to circle that. What else do we have? Okay, here's how this works, kids. First things first. Once you've established what your x-intercepts are, basically locate the x-intercepts. You just want to find what's known as the zeros of the function. Okay? So what are my x-intercept values here according to what we just solved for? 1 and negative 3. So I'm going to go to 1 on the x-axis, and I'm going to plot that point right there. Okay? And I'm also going to go to negative 3 right there. Those are your x-intercepts. Now, kids, those 2 points are on the same horizontal line, the x-axis. And if this is going to be a quadratic, kids, doesn't this point have to mirror this point right here? Okay, so kids, what's this value right here?
0, negative.
And what's this value here? 1, 0. Put a 1 up here. Now, kids, give me a second to calibrate this. I'm a little off today. Guys, what value is going to be right in the very middle of that negative 3 and positive 1 looking on your graphs right now? Okay, and a way to find that line of symmetry, locate the line of symmetry, I'm going to write this down. It's going to be your x-intercept values. Basically, what we found here, this right here, it's your x-intercepts. I'm going to write x1 plus your x-intercept 2 divided by 2. Okay, it's the average of these. Help me think about this, kids. What's 1 plus negative 3? Negative 2. Now cut negative 2 in half. Where you at? Yeah, if I take my x-intercepts right here of 1 plus negative 3 and cut it in half here, you ended up with negative 1, right, kids? Which means you have a line of symmetry at x equal what value? Negative 1, you bet. What's going on here? There we go. So at negative 1, I'm going to draw my line right there. There's your line of symmetry right there. Okay? Does that look like it's right in the middle of my two x-intercepts? How far to the right is my x-intercept from the line of symmetry? How many units? And how many units to the left? Okay, now kids, how are you going to use this, kind of like we did in standard form, how are you going to use your line of symmetry right here to find the vertex? Say it again. Somebody said something. But what did we do when we found the line of symmetry here, kids? In standard form. To get a vertex. Didn't we just plug our x value in? We did, didn't we? You're going to do the same thing, okay? Locate the vertex. So you're simply going to plug in your line of symmetry value here. All right? We need to find the y value. So using this function up here that we're trying to graph, f of x equal x minus 1 times x plus 3, we're going to say the y value equals, what am I plugging in for x right here? Negative 1, right? So it becomes negative 1 minus 1 times, help me out, negative 1 plus, all right, I know it's early on a Monday morning, kids, but negative 1 minus 1, this becomes negative 2 times positive 2, doesn't it? What's negative 2 times positive 2? Negative 4. So the point I'm going to plot, when we input, kids, when I input negative 1 here and here, what do we get for an output? So I want to plot the point left 1 and down how much?
4.
Yep, so this means the vertex is at negative 1, comma, negative 4, which would be, let's see, 1, 2, 3, 4 units down. There it is. Boom. And then just do your best to sketch a parabola through those points. Okay. So really, guys, you're finding the two x-intercepts first. We found negative 3 and negative 1. And then basically, you need to find the middle of those two values right there. In our case, what was the middle of negative 3 and 1 again? Once you have that negative 1, plug it back into the original function to get your y value vertex. And really, how many points are you looking to graph, kids? 3. And once you have that, problem done. What's the name of this form? X-intercept form is what we're going to call this, all right? X-intercept form. Okay, good. Questions about that example? I'd put a star by that because that's kind of the driving force behind everything today that we're going to discuss. What questions do you have on that? All right, well, let's see what's on the next page here, kids. This is a little different. This is a little different. It says graph 3x squared minus what, kids? 3. Boy, I don't know if I typed that in right or not. I need to double check. I think it should have been 3x that I should have put in there. What is it, 3.5 kiddos? Okay, this is correct. We're good. Example 2, sometimes to do this right here, sometimes, kids, you may have to do what's known as factoring this a little bit. We've talked about factoring before, right?
You guys are good at factoring. Guys, take a look at this function right here. F of x equals 3x squared minus 3. Is there something I could take out of 3x squared and minus 3? What value could I factor out of those? I can take a 3 out of both, right? You agree that this becomes f of x equals 3. If I take 3 out of 3x squared, what's left? And if I take 3 out of negative 3, what's left? Okay, now you guys have talked about this before. Do you guys remember what x squared minus 1 factors into? Last chapter. Got a 3 out front. You guys remember the difference of perfect squares? Remember that? Okay? Think about it, kids. What would if I FOILed this out, what would the x times the x get you? X squared, inside, outside. Negative 1 times x, positive 1 times x. Wouldn't they cancel? Positive 1, negative 1 is a negative 1 right there. So we've kind of got this back into factored form. This is kind of like intercept form now, kids, where it's like, I've got this a value up front of 3. I got an x minus 1 and an x plus 1. We're going to take these two parts in parentheses where I have x minus p and x minus q. We want to find if I'm saying x-intercept, what's another name for that? Zeros. Okay, so we're going to set those two sets in parentheses. X minus 1 equal to 0. We're going to set x plus 1 equal to 0. Kids, talk to me. What's 1 x-intercept over here? 1 x-intercept is going to be at 1. Circle that. What's my other x-intercept going to be? Negative 1. Okay, you guys buying what I'm selling so far? Okay, so let's go plot our x-intercepts. Positive 1 and negative 1. Here's positive 1 here. Boom. Here is negative 1 here. Boom. Guys, what's the line of symmetry appear to be then? If 1 and negative 1 are my intercepts. Yeah, so x equal really what value? How much? 0, you bet. Because if you would take these values, 1 and negative 1, add 1 and negative 1, kids. 0 divided by 2 is still going to be what? 0. So to find the vertex then, kids, we're going to just go back to my original function and plug in what value? So the y value we're going to look for in my vertex is going to equal that original function 3 times, what's taking this x right here? 0. So 3 times 0 squared minus 3, kids. Well, what is 0 squared? 0 times the 3 out front is still 1. Minus 3, where are we going to end at, minions? Okay, so what's that force the vertex to be? Yeah, the vertex, my friends, is equal to 0, comma, negative 3. So we're going to go on the y-axis 0 and then down. Does it make sense that this is a U-shape, kids? Why? A is positive, you bet. Okay, and I'll do my best. I have a hard time sketching parabolas on this little pad, so this might be kind of bad. This looks like a dog now. Looks like Snoopy a little bit, doesn't it? Anybody see Snoopy there? I do. All right. Hopefully your U-shape was a little better than mine. Blake, was yours better than mine? No. No? Who's got one that's 10 times better than mine?
It looks like your target dog.
It looks like what?
Your target dog.
It does. What's his name? Bullseye? Is that right? Target dog, Bullseye? Love Bullseye. I think it's Bullseye, isn't it?
Oh, you gotta zoom the dog.
All right, kids. Questions on that example at all? If I'm not able to find the zeros right away, what might I have to do to find zeros? Factor some things out. So we've got to try and revert back to some things in chapter 2. That'll come back into play. Is it bullseye?
Yep.
Kinda makes-
Bullseye is a bull terrier.
Think about the Target logo. What's that look like?
Bullseye.
Looks like a bullseye, doesn't it?
Actually, it looks like a target.
It does, the Target symbol, yep.
To
Okay.
create the signature bullseye around the dog's eye, Target uses the Humane Society approved vegetable-based cosmetic paint applied by professional makeup artists.
Sweet. Guys, we gotta find the zeros of a function, okay? I don't know how else to make this any easier. When I say find the zeros, how many parts of this function do we have that we're multiplying together?
2.
It's very simple. We've already done this. We're gonna set x minus 5 equal to what?
0.
We're gonna set x plus 7 equal to what?
0.
Okay? Find the zeros. Well, what's one zero gonna be? What's another gonna be? Okay, so there they are. There are your zeros right there. Let me make this a little more difficult on you. What if I had something like this? You guys find the zeros on your own right there. 2p plus 6 times p minus 7, what would the zeros of that function be? So what are you going to do there, guys? How many parts are you setting equal to 0 there, friends? 2 of them, you bet. Good, Daisy. Set 2 parts equal to 0, see what you get there.
What times 1 is 6?
All right, show of hands. How many have the zeros here? What are they? When you set 2p plus 6 equal to 0, what'd you get for a p value here?
Negative.
-3, good. What'd you get here?
7.
So if I wanted to graph this, kids, what values would I graph on the x-axis? -3 and 7. What's -3 plus 7? 4. Cut 4 in half. What's that 2 represent? Line of symmetry, and we would use that to find your vertex, and you'd be on your way. Okay, good. Anybody have questions about that?
Nope.
Well, let's keep on rolling, kids. Guys, this stuff is all in factored form right here. So sometimes, again, finding zeros of a function means to factor stuff. Okay, now this one here is a little interesting. I could do this a couple different ways right here. We've talked about setting something like this equal to 0. But guys, this would factor into, guys, 25 should be a dead giveaway. 25 is a perfect square. Okay? 5 and -5 would work. If you would set this equal to 0, you would have x squared equals 25, and the square root of 25 is going to be plus or minus 5. But if you didn't recognize that, couldn't this factor into x plus 5 times x minus 5? And if I set this equal to 0, here we go. Guys, if I set x plus 5 equal to 0, what's going to go in here to make that a true statement? What are you plugging in for x to make this first quantity 0? What are you plugging in here? So your zeros are going to be at x equal -5 and x equal positive 5. Now this next one's not so easy, kids. So let's try and see if we remember how to factor. What do I have to do with the 2 and the -24? Which value is that, Samo?
-48.
Very good. So we need to think of 2 numbers. You guys remember how to get to that sum and product calculator still? I'm not telling you to go there now. You should be able to help me figure this out. What two numbers are going to add to negative 8 and multiply to negative 48?
Or negative 4 and 12.
Other way around, buddy.
Negative 12 and 4.
Yeah, would this add to negative 8, kids?
Yes.
Would this multiply to negative 48? Okay, so let's write that middle term, negative 8x, as minus 12x plus 4x. So we're going to call this 2x squared minus 12x plus 4x. Guys, remember that this negative 12x and this plus 4x right here makes that middle term negative 8x, right? From factoring, last chapter. Recall that? Okay, what do I still have on the end, kids? Okay, help me out, friends. What do we do at this point now? Split it. We got to factor the left half and the right half. What could I take out of 2x squared and 12x, kids? So this becomes 2x. All right. If I take 2x out of here, what's left here? Minus 2x out of here. So it's 2x and times x minus 6. What can I take out of the front, or the second half, I mean?
4.
Take a plus 4 out. How will I know I'm on the right track, kids?
Do the same.
Yeah, the quantities, x minus 6 should match. If I take 4 out of 4x minus 24, what's left?
26.
Are we on the right track, friends? Okay, the 2x and the 4 are going to form its own group, so this factors into 2x plus 4
Let's see.
times what?
That's right.
And if I want the zeros of this mess now, kids, we would set this equal to 0. And say, all right, I think we can do this mentally. What would go in for x right here to make this a 0? Negative 2. What would go in here to make this a 0? Yeah, so what are your zeros there? Okay, all right, let's just check something, kids. I want to do this. I know I'm going kind of quickly. Just give me a show of hands. How many are on board right now so far? Take that negative 2 and 6 and add that up. Where are you at? 4, right? Cut 4 in half. What should the line of symmetry be? 2. You guys, this is in standard form up here originally, isn't it? What's the opposite of b?
8.
8. And then 2 times a down here would be 2 times 2, wouldn't it? 2 times 2 is 4, so 8 over 4 is still what value? Let's see, divided by 4 still. 2. Okay, we've talked about standard form of finding line of symmetry. Don't the line of symmetries match up the same way? We do, don't they? They were both 2 there. All right, good. Questions on the second page at all? We feeling okay about this? Give me a flex if you're good right now. Not only Gage. Gage is excited to death. Awesome. Sweet. All right, well, let's get through this last page here, kids. Ooh, I like this example right here. Okay. It says graphing a quadratic function using what, kids? Zeros. Now, this is not written in intercept form. And if it's not written in intercept form, there's a pretty good chance we're probably going to have to do what, kids? Factor. Well, kids, here's the deal. This one here is just a 1x squared. So can you think of two numbers that multiply to negative 4 but add up to 3?
Yeah, I will ask questions.
Negative 4 and 1. I mean,
Go to this percentage.
4 and negative 1.
Yeah, this should factor into, we're going to call this h of x equals x plus 4 times x minus 1. Okay? And again, how do I know I'm right? Well, I can FOIL. X and x is my x squared. What are my inside-outside terms going to combine to? 4x minus 1x, which would be what? 3x, my middle term. Okay? And then a negative 4. So kids, what are my zeros going to be? If I set this equal to 0 now,
Negative 4 and 1.
yep. So the zeros are going to be at x equal negative 4 and
1.
x equal 1. Very good. So let's go plot those, kids.
So on the left, 1, 2, 3, 4. And 1. All right, now what's next?
3, and then we add them again.
So when I add them together, I get negative 3, is that right?
That's good.
But I have to take that negative 3 and cut it in half. All right, so my line of symmetry would be at x equal negative 4 plus 1 divided by 2. What is that value, kids? Negative 1.5. So at negative 1.5, I'm going to throw a line of symmetry in here. So here's negative 1, negative 2, so I'll go right in the middle here. Is that pretty good in the middle there, guys?
Yeah.
Hey, how am I going to find the vertex now? Yeah. Now, kids, a couple of different ways. I could go back to the original equation and put this in, but I think it's easier to put it into the factored form. We could say that my vertex, we could say my y value of the vertex is equal to, what are you putting in for y, or I'm sorry, in for x now?
Negative 1.5.
Yeah, it would be negative 1.5 plus 4 times negative 1.5 minus 1 here. Okay. All right. Guys, what is negative 1.5 plus 4? All right. And this is times, this would be negative 2.5, wouldn't it? Okay, we're going to run out of room a little bit on the graph, and that's okay. But what you end up with here, kids, is negative 6.25 if you would multiply that out. So where did the vertex fall, kids? What kind of what? Negative 1.5 comma negative 6.25. All right. Let's see, this only goes down how far, kids? 5, so 6 would be right on. So wouldn't it be kind of right about here? Is that a pretty good estimate, you think, guys? If I go off the graph a little bit, you guys okay with that? And then here comes your sketch. Okay, first thing I would say, get this in factored form. Get that in factored form, friends. Once you have factored form established, find your zeros. Once you know your zeros establish your line of symmetry. And once you have your line of symmetry establishes the
Vertex.
subvertex. Very good. Okay? Establishes the vertex, all right? Okay, so I'm going to put up here in blue, over on the board here, with marker. I'm going to write this down. What's the name of this form that we're talking about today? Yep, A times X minus P times X minus Q is going to be called
Like really bad.
X intercept form today. Cool. All right. Well, here we go, guys. Then this is the interesting part right here. We have to write a function finally in intercept form that satisfies the given conditions. The first thing we need to understand is it has x-intercepts where, kids? Negative 1 comma, or negative 1 and what? 5, right? So here's how I start this out. I say, okay, we know we're going to write this in what form first? But they're giving us the what first, kids? Okay, we're going to start this out in x-intercept form, and this is going to get really kind of goofy. All right? We're going to start in x-intercept form, so I'm going to write down y equals a times. Now watch what I do here, kids. I have to write this as x plus 1, and let me tell you why. When they say an x-intercept is negative 1, they're saying that negative 1 is a value that would make this 0. So negative 1 plus 1 would make what value, kids? And then if I tell you 5 is an x-intercept, how am I going to write the second part of this? Let me guess.
Minus
X minus 5. Because, kids, if the x-intercept is at 5, that means 5 got plugged in here to make that quantity equal to what value? 0. Okay. We're good there, right? Okay. So that's the first part of it. Write this down. Now, kids, we're still trying to establish what form.
Standard.
What form am I in right now? Okay. Listen, we probably have to find a value for what now? A. We're going to use this vertex over here, which states when x is negative 3, your y value is what? Okay, here we go on this. Okay, we're going to plug that point in. So in for y, what are we plugging in? Negative 2, right? That's going to equal my a value. Okay, if I plug negative 2 in for y, what must I plug in for x, knowing that the vertex is negative 3 from a negative 2? What have I got to plug in for x?
-3.
So we're going to go negative 3 plus what first?
1.
Okay, negative 3 plus 1, and then negative 3 minus what?
5.
Okay, you guys help me out here first. All right, this becomes negative 2 equals a times, what's negative 3 plus 1? What's negative 3 times negative 5? Or minus 5, sorry.
-8.
Okay, that negative 2 and that negative 8, you agree that multiplies to positive 16? So, how would you get a alone?
About this.
Okay, so negative 2 over 16. Does that reduce at all, kids?
Yeah.
Would it be positive 1/8 or negative 1/8?
Negative.
Okay, so let me show you what's going to happen here. The first thing that we did is kind of start this out in x-intercept form. And we said y is got to equal a times x plus 1 times x minus 5. When I say the intercepts are this and this, we got to make them fit into these zeros. Then I went through and said, let's plug the vertex in for x and y, and that allowed us to solve for what value over here? Well, it allowed you to solve for what? A, right? Okay, so this is the completion of this. What I have here for a function, kids, will be the following. This will become y equals, what could I plug in for a now? Negative 1/8 times x plus 1 times x minus 5. Now, if this said write that in x-intercept form, that would be great, because that's what we're in right now. But it didn't say that. They want you to turn this into what? Okay. Well, guys, if you notice up here, does standard form have any parentheses in here? So the only thing we're going to do is we're just going to multiply this out. So let's forget the negative 1/8 for a second. Help me FOIL this. What's x times x going to get you? X squared. Okay, inside, outside. Let's do inside, outside. So 1x and negative 5x.
-4.
So minus 4x. And then last, positive 1 times negative 5. What would that be? Okay, this whole mess is still getting, we multiplied these two quantities right here. This is still getting multiplied by what, kids? Okay. So to turn this into standard form now, you're simply going to multiply negative 1/8 to every term that we just FOILed out. So we're going to end up in standard form with the following. Negative 1/8 times x squared would be negative 1/8 x squared, wouldn't it? Agree with that? Then I'm going to take the negative 1/8 times negative 4x. Help me out first. Negative times a negative will be a... Okay, if I take 1/8 times 4, isn't that 4/8? Or in simplest form? 4/8 in simplest form would be? Yeah, plus 1/2 x. And let's see, I got to take this negative 1/8 times negative 5. Is that going to be a positive or a negative, kids? Okay. Kids, what form am I in? Standard form. And let me show you how you know I'm right.
if I get into this right here, into decimals. Okay, I'm going to have you guys read me the x-intercept form first up here. So in x-intercept form, we had negative 1/8 times, what was it, x plus 1 or minus 1? I can't remember. And then times, okay. Let me put in projector mode here so we can see this a little better. Are my x-intercepts negative 1 and 5? Okay. What did we come up with for a standard form equation then? Wasn't it negative 1/8 x squared? Is that right? And then what do we have next? Plus 4x? Half x, okay. Plus 5/8? Oh my gosh, you guys. What's true about these two graphs? They're the same exact thing. So how do I know my standard form is right? Well, it matched right on top of that. Okay, matched right on top of that.
All right, you guys. First of all, question. Got a lot of information in this section here. This whole chapter's been filled